Hello, everybody, and welcome back for the customer panel. This is a live panel, and you can see we all got ourselves a little fit of the giggles about 10 seconds before we went on air. So I'm going to introduce this great panel we have here today. We've got a lot of different perspectives around the room, or the virtual room. And I think the first thing you should notice is that the lighting shows you that a lot of the panel members are actually in European locations. So a lot of people are staying up late to join this panel tonight. So I'm going to start with Sue. Sue is a Senior Analytics Solution Architect from Kensington Mortgages. So hello, Sue. Welcome to the panel. Yavor is from Vestas Power Solutions, where he's a Director of Plant Optimization, Plant Data and Optimization. Hello, Yavor. We have Stefano from the University of Bath, where he's a Senior Cloud Architect. Hi, Stefano. And then we have Rajiv from AMD. He's a Senior Director at AMD and is responsible for designing some of their future product capabilities.
Hi, everybody.
Hi. And then finally, we have Jeremy, who is the CTO at Jellyfish Pictures. Hi, Jeremy. So thank you, everybody. Thanks for joining this. We're going to try and keep the panel a little bit light and a little bit fun. Or we'll try to anyways. And we're going to start by asking the panel members to describe what new impacts or wins that have been enabled for their business by using Azure HPC and AI. I'm going to put the pressure on them to keep their answers down to 30 seconds. So like, how can you summarize the impacts and the wins that Azure enabled as quickly and as concisely as you can? And I'm going to go in reverse order. I'm going to start with Jeremy.
Sure. No, thanks for having me, and thanks for the introduction, Andrew. So it's great to be here with all the other panelists and everyone else. I just think, and really answer to your question, in the media and entertainment and broadcast sector, we're undergoing a pretty big transformational shift to Ultra HD or to 4K resolutions, and all of that extra work requires an enormous amount of processing power, and we regularly use basically the HPC cache on Azure in any cloud burst scenarios for basically doing rendering and a lot of really heavy simulation and computational work that we need to be done. So it just allows us to basically to confidently be able to really get the work done that we need to get done, and we can have the knowledge that we'll be able to deliver on content for our clients.
Thank you. Rajiv.
Yeah, again, thanks, Andrew, for this opportunity. Speaking about our experience at AMD, if some of you are familiar with, just chip design, our demand is just insatiable for compute, and it varies a lot. And for the first time after we started incorporating Azure into our computational solution, we actually have the capacity that can also vary as our demand varies. And that has been a huge impact on keeping up all this product development schedules for all the portfolio projects that we are doing at one time.
Thanks. And Stefano?
Hi, Andrew, and hi to everybody. For us, basically, the cloud allows us to accelerate the research within our academic environment. We do research, for example, in discovering new medicines or simulating engines, and using the cloud, we are able to the elasticity of the cloud. We're able to satisfy the needs of our customers in terms of compute, and also the possibility of having the variety of the cloud, so our customers can select the best option that's best for them for their simulations and for their workloads.
Perfect, thanks. And Yavor?
Hi, Andrew, and hi, everybody. Thanks for this opportunity. In the wind energy business, it's very important to be a shorter time to market, and I think that's one of the biggest advantages we have with the Azure HPC. We can also remove a lot of bottlenecks related to big tenders when we have to have massive amounts of simulations to be able to accomplish 1 gigawatt of a project, et cetera, et cetera. This is actually with on-prem solutions being always a bit of a bottleneck, and now it's removed. Of course, performance is also improved, and recently we also explored some of the AI capabilities with DeepSim and multi-thread neural network. So yeah, that's it.
Cool. And finally, Sue.
Yeah, hi. Thanks for the introduction, and glad to be here. Kensington Mortgages is a specialist lender, and it's heavily data-driven and analytics-driven. So we actually moved to machine learning algorithms, gradient-boosted decision trees for our in-house mortgage performance engine. And when we ran this on-premise, it took around, say, 20 hours. So we migrated to Azure HPC services using batch. And what this provided us was massive parallel computations, with the help of which we were able to achieve a more accurate forecast and run more scenarios, macroeconomic scenarios. And as a result of which we could understand our risk better and forecast better and design tailored products for our customers, and which means better outcome for our customers.
Thanks, that's great. And so as we go through, we have some questions that that have been shared by the group in advance. There are some questions I will ask the panel members that they have not seen in advance, and of course, your job as the audience is to try and guess and figure out which questions they've seen in advance and which they haven't. But we also welcome questions of the audience as well, and we have a team scanning the attendees on LinkedIn and the attendees on the On24 platform and picking out some questions to share. So please do ask questions from the audience as well. So I'm going to dive straight into another aspect here, which is you've been using Azure for a while. What aspect of Azure do you wish you'd known about or found out about sooner, either sooner in your usage of Azure or sooner in your evaluation of Azure? What part of HPC+AI Azure do you wish you'd found out about sooner? And I'm going to come to you first, Stefano.
Let's say that for us, it's very important the storage aspect. So basically, be able to manage the storage in an efficient way. So we want to be able to have the user data in the most efficient storage, which costs, of course, a bit more when it's needed, and then move it to a slower storage and cheaper storage when it's not needed. So I'm quite keen on the blob storage, and so all the ways to apply policies to the blob, where you can move the data from hot to cold, and so that's something that initially I would have liked to introduce and to use in my workflow, the workflows of my users. So that's my main point.
Yeah, that's an interesting one, actually, because as somebody with a very traditional HPC background myself, I would not have counted Blob as my first choice for HPC storage, but some of our internal teams have been building parallel file systems on top of Blob and delivering some pretty amazing results that is changing my mind about the nature of object storage as an underlayer for HPC file systems. I'm going to go to Jeremy.
Sure, thank you. I think probably one of the things that I think for us has been how easy it is to kind of scale very, very quickly with things like the scale sets. So we initially didn't start using them, but just to see how easy it is to really ramp up and ramp down your compute, and then the services behind them. So much like the storage, but to simply basically automatically scale and build that into your app or into your solution is pretty amazing. So if you need more computational power for an hour, a couple of hours, basically, you can just very, very easily allocate more at the push of a button rather than manually doing things yourself. So I think that combined with the recent work on Terraform allows us to use a lot of infrastructure as code methodologies, which has been really, really helpful. It's allowed us to get up and running very, very quickly.
Sure. Sue?
Yeah, I think for us, it's like what we were really amazed after working on, had we known it earlier, the configurability of these batch services as your batch. Normally people go for auto scaling, but what really helped us in our case is the configuration and the flexibility that the batch offered. I think knowing all this empowers us and to create creative solutions, which kind of slashed our runtimes from 20 hours to 25 minutes.
Sure, thank you. And Yavor?
Yes, actually, what we have been very interested in is what's the roadmap for the HBV series, and since HBV3 is the best performer currently for our needs, we wish we would have known more about what is the timeline and everything about what's coming. So that's that's our best wish.
Cool. And Rajiv.
Can you hear me now?
Yeah, sure.
So for us, one of the key learnings that we, probably didn't know as well as when we got into Azure was just how we could customize each of the SKUs. So from a chip design flows, we have a variety of flows, and there is always a particular instance that's optimal for that kind of flow. So whether it is, a CPU with more L3 cache or something with a higher frequency or something with more memory per core. It gave us the ability to then look at the flows that we were running and then optimally match the instance with the kind of flow. And one of the new kind of parameters that we included in all of our calculation as we did this was also what was the cost associated with each and how we could actually start optimizing that cost and the other factor we also looked into is when we run a lot of different things, what's really more important than other, and be able to kind of prioritize that. So the focus shifted from just trying to use what you have on-prem to really trying to use something in an optimal way. And when you kind of scale this out and when you're doing a lot of flows, it brings a pretty big impact. So.
Okay, interesting. It's interesting to hear those as we went around. It's slightly going in a slightly different tack now, just to demonstrate that we're going to talk about more than just Azure in this panel. I think we've heard a lot of great things about Azure for the first half of this day so far. I'm interested just to talk about HPC and AI in general and cloud computing in general. I'm interested to hear what the panel members think, or what's your top prediction for how HPC or AI or cloud or a combination of those is going to pan out over the next 2 to 3 years. And so we're going to start in this case with Sue.
I think the Hyperion research predicts that in 2025 there would be 47 billion of revenues coming from HPC. So what it dictates is that it's going to be a massive growth in this area. I feel definitely on the innovation and processor architecture to support a safe example in the natural language processing and the neural nets. The tabular data, especially for the banking systems, is going to be pretty useful with the advancements of GPUs. So that's something like, that's going to change the way the models are going to be trained. The other aspect is also on the continuous migration and expansion on the cloud. On HPC systems, the hybrid HPCs, I think that's going to be a lot more happening area for HPC.
Thank you. Yavo?
Yeah, I believe that more and more, of course, quals will be used in the future. In this transition period, in the next couple of years, I believe a lot of companies would use it as a bursting capability, which means they will keep their on-prem and use the cloud as bursting. And but of course, the production system, which needs a big potential for scaling, they will move to cloud. That's my explanation. I could see that working with academia, which they still develop their own codes and we still use them in the industry, and this can be one of the reasons that some solutions can still stay on-prem. But yeah, I think transition is obviously to cloud. Yeah.
Okay, cool. And so then Rajiv, and I mean, you're in an advantageous position in some respects because AMD is developing some of the very exciting technologies of the future that will end up in the influencing the future of HPC and AI and the cloud space. But so maybe you could step apart from that. So apart from AMD's amazing roadmap, what is your top predictions for HPC and AI or cloud in the future?
Yeah, so I'll step away from from being AMD, but I'll wear my IT hat on as a consumer of AMD products and just speak from that perspective. From our, when since we kind of support on-prem most of our chip design flows, so we're not as far along in terms of some of the other applications in terms of migrating to the cloud. So that journey has just started a couple of years ago. For us, the big thing is just the scale. We've been growing our on-prem pretty rapidly, and we expect we're going to probably grow at a faster pace on the cloud and be living in a hybrid environment. The biggest challenge that we see in front of us is as we get into more lower geometries for design, our computation need and storage need is just exploding at a pace that we will probably pursue every avenue that we can to grow. And that's really what we're looking at. How do we create an environment that can scale up quickly, at the same time be comprehensive enough to cover both our on-prem and the cloud? And I think when we started this conversation, someone made a comment about block storage, and believe it or not, the chip design, the whole infrastructure, whether it's the ISVs or everybody else, pretty much have been anti-block storage. But we expect that will get revisited. We expect that whole paradigm will begin to be questioned. And we're beginning to do that internally at AMD also. So I think that could be another big change because of the scaling opportunity that block storage provides, that could be another very, very interesting avenue that we would pursue. So.
Sure. And Stefano?
Yeah, so in terms of HPC, I predict that, I like to predict that basically there's going to be a bigger integration of accelerators with CPU. So basically, accelerator and CPU will be more integrated, not only from a system design point of view, but also from software development point of view. So it'll be easier for developers to develop code that has both kind of flavors, CPU and other kind of accelerators and libraries and tool chains. In terms from a cloud point of view, I predict that basically there's going to be more convergence between HPC and AI solutions, where you can basically run kind of AI workloads more on an HPC traditional kind of platform. And so I think, in terms of cloud providers, that's gonna, and also Azure, I'm pretty sure there's going to be that kind of convergence between HPC and AI.
Sure. Jeremy?
I think we're going to see more integration with other, say, certain different types of applications. So in this industry, before the pandemic hit, I was at NAB in Las Vegas, and we could see the power of AI with as much, GPUs, with these different applications utilizing GPUs to help basically say do like almost like real time like audio to text translation and that sort of stuff. I do think kind of going forward with the having as much of a massive amounts of compute on your fingertips, I think it's going to become a lot more commonplace, and I really think that we're going to see it a lot of the research that's being done. We're going to see it like a lot more integration with, say, for example, certain applications. So I've already seen that in the application stacks that we use in the industry that I'm in, and I can only seeing this progress. So I think we'll end up basically with a bunch of users that are using AI or using HPC, but they don't really know that's the underlying technology behind it. So, but for them, it's just going to massively increase like a lot of efficiencies for them.
So that's interesting. I think both yourself and Stefano have touched on that that overlap between the AI and the HPC and how AI is going to be used either knowingly or unknowingly by people using computational infrastructure. I'd like to dig into that a little bit more with some of the other panelists. So going back to Raji, for example, how is AI getting used more in the chip design process rather than the more traditional engineering-based computation approaches?
So if you're familiar with the chip design process, it's fundamentally a process of convergence. and under certain constraints. So it's a process where you have power constraints, you have area constraints, you have performance constraints, and the idea is to come up with a feasible solution that meets all your criteria. And where we're beginning to see AI come into place is to really accelerate that convergence. So what can you learn from the current iteration then that you can then maybe change your parameters for the next conversion cycle. So it's gradually becoming a more rather than somewhat of a, hey, I'm going to try these thousands of runs and see what comes out process. It's becoming more of a guided process where you try to converge as quickly as you can to whichever piece of the design you're doing. The one other opportunity that I see is eventually in the cloud, and I'm not sure when we can get there. If we have multiple companies doing their designs, and if there is a way to share some of that historical data about, for example, for a certain process from TSMC, using a certain technology from some other vendor, what is it that kind of works the best? If there was an AI machine learning tool to say for this design, hey, these are the recommended parameters that you can do and come to your results quickly. You basically tap into a broader learning than what you would do, say, within one company, because a lot of the underlying technologies are, used commonly between several companies. Now, that's probably a pretty heavy lift, but that's the promise for that is certainly out there. So.
Okay, interesting. Particularly that sharing aspect towards the end, or finding the commonality features. Yes. Sue, I guess from your point of view, how would machine learning and HPC come together, or traditional computation come together in your sector? But I guess there's also an added flavor there of the regulatory aspect to some of what you're doing, the compliance aspect. So does machine learning and the integration of HPC and machine learning cause problems there, or opportunities, or what?
Oh, yeah. It's like, for us, it's like, as I said, we are a specialist lender, although we're not like an, high street banks, but we are very niche markets. What it means is the data and analytics has to be, is embedded in our systems. We use data to make everyday decisions. What it means is like, we have a lot of machine learning models which give data insights for our servicing staff, for our originator staff, for our underwriters, using which they can tailor or choose the right type of mortgage products for our customers. And especially if you see recently we've migrated this asset performance engine into HPC services. And once you've got into Azure, now it has opened our gates to build our machine learning platform. So it's very tightly integrated because I think it goes together. I think the future is the integration that we see. Because as you build these machine learning models, you train, you serve, and you monitor. That's going to add a lot of value for the business. And also the other things that we're coming up with, how we can apply these data insights, say, for example, for your case scores, your credit scores, understanding the capacity of our underwriters. So I think it's going to pervade every space in banking.
Okay, interesting. And Yuval, I mean, in terms of moving from, we've been playing this video in the breaks today about moving from working at a turbine level to a whole wind farm level and so on. Is machine learning really helping to accelerate that process, the integration of machine learning and traditional computation?
Yes, indeed. We have recently explored this use case, which was featured in the video of wind farm control. And of course, it's a combination of you need to do a lot of flow simulations, but without the machine learning and the training of the model, that would not be so efficient. So we managed to combine that and use Azure Cloud to do this scaling. But there are also many other aspects of it which we could use in the wind business industry. One other example would be when you do a mesoscale model, the weather prediction model for the entire world. If you go with a 3-kilometer resolution, that's something feasible. You can do it on-prem. But then if you want to downscale that, because turbines obviously are placed in shorter than 3 kilometers, so then using physical models, this will throw a lot of resources. But using machine learning, and that's something that would shorten, of course, the computational time, and you can do it in a much faster way and more efficient way.
Okay, interesting. And so actually, one of the when I first talked to Vestas about HPC many years ago now, a lot of the discussion was around the site planning rather than the site operations. So it was about optimizing where you locate the wind farms in the first place. And it seems to me a lot of the recent talk has been about optimizing the operation once they've been located. Is that a true change, or is it still a lot of emphasis on the siting in the first place?
Yes, you are absolutely right. We are shifting now towards the value of energy, which means previously we would do an annual energy production estimation, like kind of average for the year. But as you know, now with all these merchant markets for energy, it's very important to have the value of energy at the right moment. So that means that you need to shift the models to how to predict how the turbines behave during the operation. That's where machine learning and HPC on big scale is helping us.
So it's interesting as we have the group here that there's a lot of different industries and a lot of different perspectives and history with computation and cloud and AI and so on. And I think that kind of opens up two questions that I'd like to dip into. The first is that the industry or the world or the consumption of computation is changing. It's changing in terms of the technologies that are available, but it's also changing in terms of the people that are making use of those technologies. So certainly from my experience of what I see from the early days of my involvement of high performance computing to now, there's much less tolerance of users on doing arcane geeky things to get the best possible performance and so on. There's a much bigger expectation on ease of use and ease of access and lower friction to getting the performance out of it. But there's other things as well. So I'd be interested to hear the panel's opinions on how you see the people side of HPC and AI and cloud computing changing, and perhaps how that's changing because of cloud. So Jeremy, perhaps you could open up.
Yeah, I think cloud on the industry that I'm in is having a massive transformational effect, and I think like even if we rewind the clock back 10 years, we could only do certain jobs because we only had like the technical backbone of X, if that makes sense. So the ability to use basically the additional compute almost on demand, and then now with all of the technologies that AI is now bringing to the table as well, and let's call them the next generation of AI tools for broadcast, I think it's going to be really exciting, and it is going to basically it is going to basically transform the sector that I work in, and we've already seen that quite dramatically. So I kind of do think it is going to be very exciting just to see where these technologies, and as they mature and develop, just to see on where they take us kind of going forward.
And Stefano, I mean, I think in the university environment, how is it changing the nature of the people you recruit to come in and run and operate and support HPC services, and how's it changing the nature of the skills a research software engineer has to have and so on?
Yeah, so traditionally, the people looking after HPC were mainly kind of system administrators, sysadmins. So we used to purchase the hardware, purchase a system, and then you kind of sysadmin. Now with this approach of deploying to the cloud, using a DevOps approach, you basically can create and destroy a cluster of thousands of nodes in less than an hour. Basically, we're looking more for kind of software engineers. So it have to be, like I said, a mixture of a developer and an operations guy looking after the software. So it's quite a change in the fact that we're using infrastructure as code is quite a change in approach that we had before. So you have to manage, basically we deploy everything via pipelines, everything is automated. And so it's quite a change compared to traditional HPC that we had.
Yeah, and so at Bath, of course, you've gone all in on cloud. It's your future, your next generation capability is wholly cloud based, which is rather from an on-prem history. How has that changed the support you've had to provide to the users of that facility in terms of training courses and documentation and so on?
Let's say that in terms of let's say we have a broad range of users because we have students to PhD students to people really expert. So our major challenge is supporting all these different kinds of users, from the guy who'd never used Linux before, he's never seen a command line, up to the guy who maybe he's basically worked on developing the MPI library. We have that kind of range of people. And another important thing is that where the cloud comes in is that the cloud will be the kind of compute of the future. So it's nice that we teach our students and our future researchers, or the researchers kind of using the cloud, because that will be kind of means of compute of the future.
Okay, interesting. And Sue, I think in your experience of using HPC as HPC, and then you've talked about dipping into machine learning, and then obviously now looking at cloud capability, what have you seen about the changes in the skills that you need, and also the skills of, or the experiences of the users of that you're interacting with? How's that kind of skills changed over that journey?
Yeah, I think apart from the technical skills, what really is helping us is the mind shift of continuous monitoring and continuous improvement. Say, for example, previously we were running batch, reduce it from 20 hours to 25 minutes. Now, when I review the design, I think we need people who can look at it from a perspective of an opportunity to improve further. So when I look at it now, there are further opportunities to improve. And say, for example, I might be using a particular algorithm now to do some machine learning, but in the future, say, algorithms are changing, So we need that design. I think we need architects and designers who can design for extensibility so that we can adopt and integrate new features coming up day in and out. I think it's that mind shift of looking for opportunities and seeing how we can help the business.
Interesting. And Yvonne, how do you think the people side of HPC has changed over your involvement with using HPC investors?
Yes, I think it was a quite sharp change. We are still in this period of transition. So, but yeah, we moved through 4 generations of on-prem supercomputers, and each time we had to design them, etc., etc. So the teams that worked on that have this background, and now moving to Azure cloud, then they were lacking some of the skills that are needed because of the specifics, and yeah, we needed to be trained. That's it. That's the thing. There is change, obviously.
Okay, interesting. And so, Rajiv, I think you've obviously, as an organization, used both on-prem and you have your own on-prem clusters, and you are using the Azure infrastructure. How have your teams had to change to be able to deal with, or to learn how to take advantage of things like dynamic scaling, and that comes with using the cloud resources? How's it changed their thinking about the workflows they're able to process?
Yeah, thanks, Andrew. So, like I think Stefano mentioned earlier that, they used to hire a lot of, system administrator type of skill set people. What the shift that we have seen is really in 2 directions. One is happening now, and one I think is imminent. So what we have seen now is we hire those engineers who actually understand the flows that we're running, and they're not as concerned about system administration aspects of it, because that's pretty automated these days. So most of it is outsourced. But the key value that we bring is really understanding the flows and understanding how best to structure the compute to do those flows. So for on-prem, it has a lot to do with how we optimize our scheduling, how we optimize our configurations, and similarly for the cloud, it's also how do we optimize our SKUs to match the workload so we can get an optimal set. And then because we have both on-prem and the cloud, then it boils out, the question then comes, okay, how do we distribute it? What should run where does it make sense? So it's kind of moved to the higher level where it's more of an optimization. So that's kind of one end of the spectrum. And the other direction that we're moving in is to get into more specialized computing, which is really to meet some of the performance requirements that you can't quite do with regular HPC or general purpose computers. So most of the commodity type computation we can do it on the cloud. The ones that we're looking at is integrating FPGAs into our servers and then doing emulation hardware. So there is another class of people who kind of moving somewhat deeper into the technology stack, and then some of them are moving much higher up on the stack where it's at the higher level, just looking at optimization. So I think that's the shift that we're seeing on our side. So
okay, interesting. And so changing direction a little bit, Stefano, maybe if you could talk a little bit about the University of Bath's journey to the cloud, how long it took, and how soon you started seeing value in that process.
Yeah, so we started probably about 2.5 years ago, and we started initially with analyzing our users' needs and analyzing what our kind of workflows were, what because the difference with our industry compared to other industries is that we actually support hundreds of different kinds of software. So we're not kind of only computational chemistry or only fluid dynamics. We basically support a very, very wide range. So we started off with that analysis, and so we identified a certain amount of workloads that were kind of about 10 workloads that were significant to us. And then we ran a pilot project for about 9 months on Azure, where we basically checked that the performance was what was expected. We compared performance in Azure against the performance on-prem. And that was very successful. We had really good results, and Azure performed really well. Then we went up to our kind of executive board, which made the decision that, yes, the cloud is a good option for us. And then basically we started in earnest with our first production systems. We started off with the teaching workloads, teaching kind of courses, because those are a bit more, I'd say, smaller and more niche. And then we started migrating our research users into the cloud. So it took us quite a long journey, and we're still not kind of there. We're still doing changes.
Okay, interesting. Yeah, and I think that shows that you have to go through those stages of proving out and testing and evaluating as you go, and unlocking the early wins, but then also figuring out what else you have to change, both with how you've implemented Azure, but the business processes of your own organization to actually be able to take advantage of what you can see as the benefits. Jeremy, I mean, was your journey similar?
I think our journey was similar. I mean, we've been using Azure for several years now, but just one thought I had is, I think depending on the type of organization that you have, and depending on like where you're at from an IT stack already. So say, for example, I mean, if you use things like containerization and Docker and that sort of stuff, you may be able to find that it's a lot easier to migrate those workloads to the cloud, because it's in a very transportable way to begin with, if that makes sense, compared to basically just having a NAS on-prem and that sort of stuff. So I think everyone's journey is going to be to the cloud is going to be different, but it just depends on what are you doing today as an organization, and how easy is it to shift. When we basically started going to the cloud, we used a lot of traditional stuff, and we worked really a lot with the Azure team on helping basically take our workflows to the cloud, and also working with them on solutions, because we could definitely see the advantages that would bring. And we started several years ago now, and it's getting better all the time as the relative, like, certain parts of Azure are catching up, and as we change some of our internal processes. So I think in hindsight, it's we're still getting better. We're still doing a lot more to really get the best value out of it. But obviously, like, the pandemic has just shown that basically you can take these workloads to the cloud, and they do work very, very well.
Sure. Yeah, Yavor, was yours a quick journey or a longer journey? Lots of steps?
So for us, we are actually in the beginning of this journey, to be honest. We have started, of course, more than a year ago with a couple of proof of concepts, and they were very successful. For me, the key is working with the right partners. If you don't have the experience, of course, yourself, then you have to team up with consultants or more experienced in the area, and that's what we have done, and with different partners. And actually, step by step, we are moving now our production systems to the cloud, to Azure, and that's coming. But again, the initial steps, small steps, get somebody experienced. That's my advice.
Sure. And Sue.
Yeah, it's been 18, 20 months that we started our journey to cloud. But I think, as all said, that we started with a discovery phase. And we have different horizontal departments, like quite varied, the analytics team, the data team, the traditional software development team, and the various teams. So there was discovery phases with our cloud partners, trying to segregate the various workflows that we have. And the analytics team was chosen to be the first one because we had a pressing need of reducing the execution times in our case. And it was so exciting because it was the first project for us. And it's like, because the organization looked towards that, right? You want the first project to do really well. But what really helped us was, working along with the Microsoft team. Microsoft was with the journey, with our journey throughout this particular migration. The HPC team directly got involved. They validated the design. That gave us a lot of confidence because the first time when you're moving into an HPC zone from an on-premise zone, you need that someone to work along and validate your design. So I think that was super helpful. They were responding to all our queries and the checkpoints in various phases. And once we were in cloud, and what really amazed the organization is it's basically with the HPC, it is the the cost versus the performance gains. But actually, with the we used FSV2 series, and it was such good economics that we got out of it. And now, because of that, that's a host of models waiting to be moving into cloud. I think it's that confidence that you gain once your first project goes successful. Now everyone is buzzing about moving into cloud. I think it was a great journey, and it's a row of projects waiting to move now, and it works really efficient for us.
Thanks. And I love that everybody who's spoken so far has talked about the fact that it has been a journey, that you're still on the journey, but all of you have got use cases are out there showing what you have already achieved in a production mode with Azure, and yet you're all talking about what more there is to come, which is just amazing to hear. Is that the same for you, Rajiv, and that you've already achieved much and there's so more to come?
Yeah, Andrew. So yeah, you're absolutely correct. So we kind of, when we planned out our cloud journey, we looked at it in kind of 3 phases or 3 steps. The first phase, and this is speaking for the engineering flows. The first step for us was to just qualify a small subset of flows that we thought were going to be suitable to run on the cloud in a hybrid environment. So these are the flows where the data was on-prem, but then we could just burst into the cloud. So once we achieved that, and we had these 5 flows that we could run, and we would run them just on demand whenever we needed to. The next step we did was do what we call the lift and shift. So that was phase number 2. So lift and shift was, we took an existing project and without making any changes to the flow, or we took the project and took the data, and we hosted the data and the flow in the cloud and just started executing the full project over there. So that's kind of where we are in production. We're running our burst computing, and we're running our sustained computing in a lift and shift mode. The third step for us, which we're still working on and that we plan to phase out sometime in the next quarter, is our overall multi-cloud strategy and flow. So the big changes that we'll see over there is, one, we are going to take more advantage of the cloud native storage. And that is a big optimization step for us, and it also helps us to scale. And the other piece is we will have the same cloud, that we can, do a multi-cloud strategy with the same flow, and the same flow would then run on-prem also. So that is what we're very excited about, and that is a third step in the journey. There's more to come after that, and incorporating more of AI and machine learning, not just in the chip design process, but it's also in the scheduling process, and how do we really optimize how we run on the cloud. But the most interesting thing is a big part of the effort is going to be just looking at how best to optimize the workload, both from a performance standpoint and from a cost standpoint of the cloud. Just because now we'll do it because we can, and we're not bound by whatever we have on-prem. So I think that's going to be a big journey for us moving forward. So.
Okay, interesting. So just building on the topic we've been discussing there, in tomorrow's agenda, we have a series of hands-on labs, essentially, which shows a number of different paths to getting onto Azure and helping people take these early steps of figuring out what works, standing up an environment, testing things, and actually then deploying production environments. So if you look on the agenda page, you'll see those for tomorrow. There's actually a question from the audience around that. Those sessions are only available to registered attendees, and there is a cap on the number of attendees that can attend those sessions because they are hands-on. There are still spaces on some of them. I think one of them has closed capacity. So you see the slide putting up on the screen there, just to show that there are a range of different sessions available tomorrow. But yes, in answer to the question of the audience, they are registered attendees only for capacity management. But they're open to anybody as long as you register. Moving on a little bit onto another topic that I guess again follows on from what we've been talking about here about that journey to Azure. In your journey to Azure and your subsequent experience of using Azure, what aspects of Azure or Microsoft for HPC+AI has stood out for you compared to other providers of HPC+AI, whether those be cloud providers or on-prem providers? What stood out for you about Azure? And Jeremy, perhaps you could share.
Yeah, I think one thing for us that kind of really stood out is that how focused Microsoft was willing to say, we wanted to work in a hybrid scenario, because we have quite a bit of stuff in our own data centers, and we wanted to distribute that load across basically our own resource, and then to kind of stretch that into the cloud. And it was great when working with the guys at Azure. They totally got that, were supportive. Rather than just taking the entire workload, because we wanted to use obviously what we existing had. So that was one of the key things that really stood out for myself.
Okay, interesting. Yavor.
Yes, very similar experience with a highly professional team from Microsoft helping us. And actually, we haven't got experience with other providers, to be honest. On the AI side, I would say we also been engaged with traditional vendors which provide AI capabilities, and we are still teaming up with them, but they are partners of Microsoft, and actually we work all together in this journey.
Yeah. It's interesting that you both mentioned the people side of it and the team side of it, and Sue talked about that in one of her earlier discussion points. That's interesting. I think we also have some, there's technology differences as well as the people differences. And a lot of it is, as with all big companies, perhaps tinted by the particular parts of Microsoft you engage with and so on. But it's true to say that even between Microsoft and a traditional on-prem provider, there are differences. No two companies are the same interacting with any one customer. And that kind of reminds me of a topic that came up in the previous session that Tim Cowell was running, where there was a question around multi-cloud. And Tim started out by saying that, multi-cloud is a path that the industry is going down. And I was kind of twitching in the background because I have opinions about that. And it has been said that multi-cloud is silly, and it's been said probably by me that multi-cloud is silly because it means accepting the lowest common denominator. If you want this theoretical portability where you can move your workload from cloud A to cloud B to cloud C in the lightest possible way, you're effectively giving up the ability to exploit the unique advantages of each of the different cloud providers. So what do you make of that, Stefano? Is multi-cloud silly? Is it kind of removing the differentiation, or is it the inevitable path anyways?
I'd like to extend the concept of multi-cloud, if I may, to different types of approaches. So multi-cloud, you can have a solution across multiple cloud vendors, different cloud vendors. That's one kind of multi-cloud. Another multi-cloud could be basically, as Andrew, you said, basically the possibility of porting a solution to another cloud vendor. But there's a third option would be maybe having a system that dynamically chooses a cloud vendor based on certain parameters and criteria like cost and performance. So there's different kinds of approaches to multi-cloud, but in terms of HPC, I think you always have to look at which cloud providers can provide an HPC solution, and that is valuable to the customers, because not all cloud providers at the moment can provide a good HPC solution, in my opinion.
Okay, interesting. Sue, what do you make of the multi-cloud is silly comment?
For me, it's like, coming from a banking sector, it's a regulatory obligation for us. When you have a dependency on a single cloud provider, we're supposed to assess the risk, have backups and mitigation. So in this case, in fact, it's a driver for multi-cloud. We have to look for these options. And in fact, it's not a bad idea because it gives you multiple benefits. Say, for example, you avoid the single point of failure, right? And you cut down your risk. Say, for example, just Elon Musk comes with a platform, with a cloud, which can cut down your costs by 2/3. And if that's your organizational priority to cut down your costs, then naturally you would want to, port your code or your models into a different platform. So rather than thinking late, which is going to kind of increase your cost, embedding that thinking of multi-cloud at the start is definitely an advantage. And in fact, for me, that's a driver for innovation, like building your apps where you build once and run everywhere. I think it's going to give new ways of design.
Sure. And I think that's very true, that because it's not only the portability aspect, but there's the advantage that each cloud provider has unique capabilities to bring to bear. And sometimes being able to take advantage of each cloud provider's unique capabilities is valuable in itself. I mean, Yavo, do you have a view on that?
Yes, I share the view with my colleagues here. I would say economically it makes sense to be cloud agnostic for the reasons which you just mentioned. But at the same time, if you want to use all the benefits of one of the providers, then yeah, you have to engage deeper with it. And we have actually also have been looking, and actually in some other areas, not HPC, we just went into solutions that are wrapper to the clouds and can choose the best in terms of price and performance solution for you from among the different cloud providers. Yes, this is also a good approach, I would say. But not in the HPC area. We haven't tested that in the HPC area. It wouldn't work, I believe.
Yeah, it'd be interesting. It'd be interesting to see what the opportunities are, because I think, as Stefano said, there's different flavors of multi-cloud as well, where there's dynamic opportunities, there's failover, and then there's switching, but porting statically at the end of a contract, for example. We're into the last couple of minutes, so it's that time where we try and give the short soundbite answers, or the snappy answers. So I'm going to go around the panel. I'm going to ask for, in a short 20-second burst, what is your one piece of advice for others who might be considering renewing their HPC infrastructure, looking at Azure, or looking at cloud computing in general? What's your snappy piece of advice? And we're going to start with Stefano.
Yeah, I think I'd like to reiterate something that Yavo said. Basically, I think it's very important to find somebody who can guide you in this process, a consultancy with professional knowledge, and because cloud and HPC are quite new concepts put together. So you can't just I wouldn't really start the journey on my own as a customer. Let's say I would try to find somebody who can recommend and suggest and give me some input on that.
Sure. Okay. Rajiv, what's your snappy advice for somebody who's looking to reevaluate their HPC infrastructure?
Yeah, in order to, what Stefano has said, and I totally agree that, bring in expert help. The other I would suggest is that also be very honest when you take a hard look at your own on-prem infrastructure. It's not something that, you necessarily have to do if you're pretty much on-prem, but if you're thinking about the cloud, just will get a very good perspective of what your current footprint is, what the capability is, and what your expenses are. as you kind of plan out the cloud. So,
okay, interesting. So,
I think for me, it's like, especially HPC, when it comes, when you have your complicated designs, look out for the right partner to validate your designs, take help from Microsoft, ask for help, don't shy away from help. There's a lot of resources, ask for help. And one more thing that really helped us is in terms of this cost versus performance, that's what we are all moving into HPC for. Designing a controlled, governed environment where you can experiment on really helps you to, save cost and monitor and control your cost. I think that's a piece of advice for them.
perfect, thank you. And Jeremy?
Yeah, I think just to echo a lot of other people here, just if you're taking a look at migrating these workloads to the cloud, I mean, there's a ton of resource online, and really engage with basically someone who's been there, done that, and got the T-shirt, so to speak, and because they will probably be able to take a look at your specific workload and use case and how to best take that workload, because there's many different types of HPC workloads out there with different requirements. So it's that'd be my recommendation.
Brilliant. Thank you, everybody, very much. It's been some great advice. There's some great discussion. It's been a good panel. Thank you very much for joining in. I hope you found it useful and interesting too. I'd just like to quickly close out by talking about the agenda that's available tomorrow. So there'll be some slides coming up on the screen in a second. So we have, as I said before, these hands-on lab sessions tomorrow. So we're actually going to start the day with a talk about a deeper dive into the architecture and platform strategy around high performance computing from the engineering team that's deploying that stuff. And then we're going to talk, we have these hands-on lab sessions where we're going to dip into standing up and running different types of environments in Azure. So on to the next slide. Both in terms of what you're going to learn about tomorrow, but also what we've been talking about today, there's a series of useful links that are going to be shared out as part of, in fact, they're available on the event website as well, but they'll be shared out with the materials when we share these out later, where you can learn some more about what the HPC+AI infrastructure Azure is, the learning tools that are available to how to make use of that, plus, of course, great case studies from our panel members and other organizations that are using HPC+AI. And then one more slide, I think. Like all companies who are doing great things, not only our customers like to showcase what they're doing, Azure likes to showcase what we're doing as well. And so there's been a series of blogs over time where we've talked about the successes we've had, particularly in some of the community standard benchmarking exercises around the top 500 list or the MLPerf results and so on, where Microsoft has been deploying and significantly sized supercomputers on the top 500 list. Was talked about earlier today, the number 10 system, for example. And the fact that we're introducing the Milan X CPUs in the near future, and we're delivering these capabilities to the market ahead of other providers, either on-prem or other cloud providers. And then on to the final slide. Again, there's a series of links here where you can find out more information, either a tech community, which is very technical focused blog material, the formal documentation, software stuff on GitHub and so on. And so with that, I think that's the end of that short slide summary at the end of it. I'd like to thank again the panel members. I'd like to thank the audience for joining in, and I hope you found it useful. Thank you, everybody, for attending and joining today.